Solving a motion problem. Let's check it out. Example number 4. So on a bicycle ride, Van can travel 50 miles in the same amount of time that Ivy can travel 40 miles. Determine both bicyclists' rates if Van's rate is 2 miles per hour faster than Ivy's. All right, great. So let's check out, first of all, what is it that we're trying to figure out? Well, it says right here, if you look on the very end right there, that we need to figure out both of these guys' rate, right? Determine both cyclists' rates. Okay, so that's what we're trying to figure out. So maybe we'll just say, we'll just let x equals IVs, or Vans, I don't know, I mean, does it matter here? Well, this will be Van's rate, and then y will be Ivy's rate. Okay, and again, these are arbitrary, so you can let y equal Van's rate and x equal Ivy's rate. It doesn't matter. Okay. All right, great. So just like on our example number 3, we made this cool little table. I think I have it on here still. Let's see. Yeah, we made this cool little table here. You know, anytime that you see a mixture problem, we always use this kind of setup. So in the same way, I kind of have a setup that I can use as well when we do motion problems, you know, like on a boat or riding on a bicycle or in a train, like all those, you know, type of things. And so, you know, like it'll look something like this. So we'll just do those two guys there. I think we'll do one more there. Yeah. And then just go across and then go across right here. Great. So what we want to do now is we're going to label these guys. So we're going to do distance equals the rate multiplied by the time. Okay, so we have our distance here, our rate, and the time. And then here we'll have the name of our two bicyclists. So we'll have our Van and Ivy. Okay, so this is kind of how that whole little system works right there. Cool beans. So let's go through each of what we know and we'll go from there, all right? So we do know that both Van and Ivy, they give us their distance, right? Van traveled at 50 miles and Ivy traveled 40. And the rate of Van, we said, was x, right? So the rate of Van is x, and the rate of Ivy, we said, was y. But what about the time, right? So we don't know that, but we do have a clue here that they did it in the same amount of time. Okay, so basically these two right here, we're gonna set those equal to one another because that's what it says. It says that they did it in the same amount of time. But we can manipulate the distance equals rate multiplied by time equation. We can manipulate it by dividing both sides by r. And so now time is equal to, distance over r, right? That's the same thing. So time is equal to distance over r. So time here is distance over r. So 50 over x. And then here's the same thing, 40 over y. Okay? So now we need to create two system of equations. Well, we do know that this is going to be one of them right here. Okay, one of our system of equations is going to be 50 over x is equal to 40 over y, right? Because we know that both of the times are equal to one another. Okay, we can't set these equal to one another because we don't think that the rates are not the same. Actually, we know that they're not the same because it says Van's rate is 2 miles per hour faster. And we know that the distance are not the same here. So this is how we use this to write one of our system of equations. I'm just going to cross multiply this by xy and that by xy so that we have something a little bit easier to work with. The x's cancel, so we're left with 50y on the left. The y's cancel, and we're left with 40x. Okay, so we're going to use that one. Okay, and let's see, we want to use a second one. Let's see, if we look right here, it tells us that Van's rate is 2 miles per hour faster than Ivy's. So check this out. So Van's rate is 2 miles per hour faster than Ivy's. So it's Ivy's rate plus 2 miles per hour more, right? So that's how much more faster it is. So now we have our two system of equations. 50y equals 40x, and we have x equals y plus 2. And this looks like a pretty simple solve by substitution, since we know what x equals, right? We know that like x equals y plus 2. So that means I can replace this x with y plus 2. All right, so let's go ahead and do that then. But not with yellow. I don't think we can really see that. So we have, let's try that one more time. There you go. So 50y is equal to 40 times x, which is y plus 2. Cool, so let's just solve this quickly now. 50y is equal to 40y plus 80. Again, that's 40 times y is 40y. 40 times 2 is 80. Subtract 40y, and I get 10y is equal to 80. I divide both sides by 10, and I get y equals 8. And it's 8 what? It's 8 miles per hour, right? Great. But now we need to find x, or VIN. So that means x is equal to y plus 2. I know what y is now. So x must be 10 miles per hour. Great. So I have 10 miles per hour and 8 miles per hour. So for VIN, it's 10 miles per hour, and IV is 8 miles per hour.